Welcome, students. Today we are going to do yet another chapter of physics, that is sound. Okay. So, like I'm talking, right? Sometimes you play at your desks by just, with your hands, and you might have seen different kinds of instruments, and, you listen to a lot of music, different kinds of beats you hear. You might like, pop music, you might like classical. So all those, world of music and talking and discussions and debates, that wouldn't have been possible if there wasn't existence of sound. Okay. So to explore what exactly the nature of sound is, on how it propagates, how it reaches to you. If I'm speaking something, or if you're sitting beside your friend and they're talking or whispering, how you're able to hear it. Okay, so what exactly sound is? Sound is nothing but it is a form of energy, and it produces sensations in our ears. Okay, and what happens you know, it actually does not, go ahead and like it is a form of energy basically, to tell you, and it travels by pushing the particles present in different kinds of states of matter. Now, what do I mean by that? Let me just tell you once. Okay. Okay. So what happens is, for example, let's say, okay, sorry, just give me a second. Okay, right. So what happens is, suppose if the energy is passing through this area, okay, and it starts hitting this particle, so these particles will start vibrating left and right. Okay, they will not move along with the energy, they'll just move left and right, and this will tend to push the next particle present next to it. Okay, so now these set of particles will move, then again the energy will be passed on, then these set of particles will move, and so on. And that way, if you have talked something, if you were saying something, okay, that will reach to us. Okay, maybe some bird, okay, here if it is chirping, then it will reach to our ear. Okay, from these movement of the particles. Okay, so sound always caused by the vibrating object. So suppose if you are sitting on a desk, you can put your head on the desk, and then you can maybe hit the this desk with a different kind of tone which you can make or something. So what will happen, you will notice a vibration. Okay, and that vibration is because the objects are vibrating, the particles are vibrating, and that is creating disturbance, and that disturbance is reaching your ear and making it look like a sound. Now the guitar strings, you might have seen that vibrating strings here will create a amazing sound waves. Okay, now if we talk about vocal cords, so our voice comes from the vibration, right? Here the vocal cords are there in the throat. Okay, so when it vibrates, then only we get the sound out. Okay, and vocal cords when passes, like when air passes through it. Okay, so it vibrates because air is passing when we are gasping in air and we are taking air in, so it vibrates. Speaker, the diaphragm of the speaker vibrates, produces the sound we hear. So this is all what exactly a sound is all about. Now, what kind of wave it is? So it is a mechanical wave. What do we mean by mechanical wave? It requires medium to travel. Okay, it cannot be without a medium, because you already know that when the sound energy is moving, it helps the particles to move, right? The particles will start vibrating, and because of the vibration in the particles, what happens is the sound will travel. So it always needs a medium. The medium could be any state of matter, that is solid, liquid, or gases. But for example, let's take outer space. So in outer space there is no air. Okay, so what happens, the sound will not travel. So sound cannot travel through a vacuum like space, but there are no particles to carry, because there are no particles to carry the energy. Okay, And also, so first thing is sound is a mechanical wave. Second thing is the second characteristic we can say or nature we can say would be, the longitudinal waves. So sound is longitudinal wave. What do we mean by that? That there are regions where the particles are pushed together, that high pressure region, and rarefaction. So regions where the particles are spread apart. This region is going to be compressions, and this is going to be rarefactions. Again compression, rarefaction, then again compression, then rarefaction. So what happens, you can imagine, like, okay, you can imagine bunch of people are standing like this in a line, in a queue. Okay, now what will happen? The one person got a push from behind. Okay, so imagine it like particle only. So one person will be pushed towards this person, right? And the rest are standing normally. Okay, then now this push will be, this person will vibrate, right? This particle will vibrate and push it further. So now this person and the first one who was being pushed, he now is, or she now is standing straight now. Okay, so now this person will be pushed towards this, and rest everything is at its own place. Okay, then again you will see the first, earlier particle came into place. Okay, exact place, same place, but now this push is being transferred. So now you can see in this case, this area is of compression. In this case, this area is of compression. Then this case, this area is compression. Now, if you're talking constantly, there will be area of a lot of areas, like alternatively, there will be areas of compression and rarefaction, like compression, rarefaction, compression, rarefaction, compression, rarefaction. Okay, so this is how a sound travels in a longitudinal way. So such kind of waves are called as longitudinal waves. Okay, right? Now moving ahead. So there are few characteristics of sound. So the first is frequency. Frequency is the number of vibration per second. That how many vibrations happen in the particles in 1 second. Okay, and it is measured in hertz. So this decides that what is going to be the pitch of the sound. So usually girls have higher pitch. Okay, the shrillness in the voice. Shrill. Okay, shrillness in the voice is due to the high pitch. The pitch is high because the number of vibrations per second are a lot. Okay, so particles are like moving very fastly, you can say, or very rapidly, and because of that, the frequency is more. And if the frequency is more, that means the pitch is more. That means the voice would sound like this, maybe, or more, in pitched manner. Okay, so it can be, like this. Okay, so you can imagine. Okay, so don't go and tease your friends for this. This is just, the frequency of their voice or their sound. Okay, the frequency is more. In your voice, it may be less. Okay, now coming to amplitude. So amplitude is the maximum displacement of particles from their rest position. That means, for example, if a particle is resting here, okay, so how much displacement occur when the energy was traveling? Okay, if it is more, amplitude will be more, the loudness will be more. Okay, people will be very loud. And if the amplitude will be less, the particle will be less. It will be less. Okay. Now, if we talk about wavelength. So, wavelength is the distance between two consecutive compressions and rarefaction. So, suppose, let's talk about compressions again. So, these are the particles like this. Sorry. Okay. So, these are the particles. And this is the again particles, but in rarefaction mode. Now again compression, okay, and then rarefaction. So like this only, what happens is, if we talk about two consecutive compression and two consecutive rarefaction, that tells us the wavelength. Okay, so wavelength is nothing but the distance between the two consecutive compressions and 2 consecutive rarefactions, and it is measured in meters. Now, lastly is the speed. Speed is how fast sound travels through a medium. Depends on the type of the medium. So, for example, it is given by, speed is given by basically frequency and the wavelength. Okay, frequency into wavelength. So this is all about the characteristics. Now, how the sound propagates. So this we already know that there will be vibration source. Okay, because of some, sorry, yeah, just let me move my face here. Okay, right. So vibration source, an object vibrates, creating compressions, high compressions, and rarefactions, low pressure in the surrounding medium. Now, example is vocal cord, guitar strings, speaker diaphragm. So an object vibrates and it starts creating the compression and the rarefaction we talked about. Okay. Now, medium particle. Second step would be it will find some medium particle. So the disturbance will be traveling around from particle to particle through the medium. Now, the particles oscillate back and forth, like I told you, like this and this, right? And lastly, reception. Vibrations reach our eardrum, okay, which vibrates in response. So, eardrum response, like its response is vibration, and these vibrations are converted to electric signals that our brain interpret as a sound, and we recognize that sound. So the speed of sound is different. Okay, the speed of sound depends on 2 factors, the type of medium and the temperature. If the temperature goes up, the speed will be faster of the sound, because the kinetic energy will increase, right? And the particle will move faster. And because of that, the speed of sound will increase. And medium, let's talk about. So if the medium is solid, the sound travels faster. So, for example, in steel, it is around 5,000 meter per second, and in water, it is 1,500 meter, per second, and in air, it is 343 meter per second at 20 degrees Celsius. Okay, so this is all about how, so fastest in solid, then liquid, and then gas. That is the speed. Okay, now if we talk about, okay, let me just take this once. Ignore this. Okay, so sound in different mediums. So solid, like I told you, particles are tightly packed with strong bonds. So if one particle is vibrating, it immediately send the vibration to the other one, then again immediately. So they are so closely packed like this, right? Here it is a little bit far, and gases, it is very far. For vacuums, if we talk about, no sound propagation, because there is no particle, only particles not available. Okay, so sound won't travel at all. Now, real life examples, if we take, so sonar, what happens basically, the sound or echo will be sent into the water. Then water will, the water particles will go, like the sound will travel with the water particles and reaches to a point where something is there to detect something, right? And it struck it and then comes back. So we calculate the distance and the speed and all, and from that we calculate the distance, that how far something is from us. Even to, how far enemy submarines are there, we use sonar. Okay, ultrasound is where the high frequency sound waves create the image inside a body. So ultrasound is done during pregnancies and all, right? So it is much safer than other, X-rays and all. Okay. Now you can answer these questions. So first one is, sound cannot travel through solid, liquid, gases, vacuum. So it cannot travel through that, you have to tell. Okay. In which medium does the sound travel the fastest? So air, water, steel, and vacuum. And last is, the speed of the sound depends on medium, temperature, both medium and temperature, none of these. Okay, so we have studied about the basics of the science. We saw how the energies, forms of energy are there, and by vibration, how it is being, the sound is being transferred or transported, you can say. What kind of mediums does it require? Does it require medium or not? We saw on what factors sound depend, like for example, the medium and temperature, and we also saw the properties of the wave. Okay, so thank you so much for joining the session. I hope you enjoyed and learned a lot of things. Okay, if you have any doubt, just feel free to ask me on my Urban Pro profile. Okay, take care. Bye-bye.